Hi, so today we are going to start chapter one, and chapter one is all about analyzing different types of data. So, specifically in the first couple of days, we're going to focus on analyzing categorical variables, and we'll talk about that distinction in just a minute here. So, in section 1.1, which we'll take a look at today and tomorrow, you'll be able to identify different types of variables and then also be able to graph categorical variables using a few different methods. So when we talk about statistics, we're really just talking about data and how we can analyze that data and make meaningful conclusions from it. And so here we're talking about that data analysis process, which really is kind of this cyclical process that we'll talk about throughout the course of the year, where you collect this data and then you display it in some way and then make conclusions or ask and answer questions using the data that's collected. So, some vocab terms that we have, one of them is what we call our individuals. And so, a lot of times we consider individuals as the people in our study, but they're not limited to people. We can also talk about the individuals being animals or objects or other things that we are collecting data from. And then the variable is any characteristic of that individual. When we talk about variables, there's a very important distinction that we have. We have two different variable types. The first is a categorical variable, and we're going to focus on categorical variables in section 1.1. Something is considered to be a categorical variable if it places an individual into a category or a group. Another term for categorical variables is qualitative variable because it's looking at qualities of an individual. But in terms of AP statistics, we call it a categorical variable. The other variable type that we'll focus on in the next section is what we call a quantitative variable, and this is a variable that takes on a quantity or a numerical value. It is important that we add the distinction that it makes sense to find the average, because sometimes a variable can take on a numerical value, but it wouldn't make sense to find an average, and then it would be thrown into the categorical variable category. So for example, if we were talking about grade level, we would talk about you being in 9th grade, 10th grade, 11th grade, or 12th grade. And while that's a number value, it's actually going to be here a categorical variable because you're putting an individual into a category based on grade level. And it wouldn't make sense to find the average grade level of students in this class, for example. So in terms of our graphing that we're going to do, and then a lot of our number crunching or numerical analysis, we want to look at what we call the distribution of a variable. And the distribution of a variable in general tells us what values that variable takes on. So sometimes if it's quantitative variable, it would be the range of numerical values. If it's a categorical variable, it would just be the different outcomes that we could have, and then how often the variable takes on those values. So if it's categorical, we might look at the number of students having each of a particular hair color in this class, and we would just look at how many students fell into each category. If it was quantitative, and we have an example here about the miles per gallon of certain vehicles, we might be looking at then those numerical values. So in this data chart here, the lowest mile per gallon here is at 14, and then it looks like the highest is up here at 33. So the range of those values would be between 14 and 33, and then we can see here in what we call a dot plot, and you'll learn more about these later, how many vehicles had that particular gas mileage. So in the dot plot, we can clearly see that there was only one car with 14 miles per gallon. We had here 3 cars with 28 miles per gallon, and we can see those particular values in the dot plot. So you're going to see exploration of data throughout the entire scope of this course. And what we're going to really start with is just that distinction between categorical and quantitative variables. And then once we make that distinction, we're going to go ahead and start to examine the data. So oftentimes we're going to start with a graph. So here you can see the graph that we saw in the previous slide of the gas mileages. And then we'll look at numerical summaries. And so this here is just a screenshot from the graphing calculator. That's not something that you need to know how to do at this point or even how to read at this point. We'll take a look at that in section 1.2 and beyond. but just looking at those number summaries. So here, just to give you an idea, this first line here where it has the X with the line over top of it, that's the mean or the average. So it tells us that average gas mileage is 27. But again, that's not something that you need to be concerned with at this point in time. We'll focus on that next week. So when we talk about statistics, one major piece of this course is what we call statistical inference, and we'll get to that basically in the second semester. And statistical inference is basically what can we infer or what kind of claims can we make based on the data we collected. So the way the process works is that we have this population. So over here, the population is the entire group that we would like to draw conclusions about. But it's not really realistic for us to collect data from the entire population. That's something that's very time consuming. It's very costly. Think of the US Census. It takes them a long time to get in contact with everybody in the United States. So typically what we do in statistics is that we look at a sample, which is just a subset of the population of interest, and we collect data from that sample. We want to make sure that that sample represents the population well. That way we can actually make claims about the population in the long run. And we'll talk about taking good samples, I believe in chapter 4. And then once we've collected the data from the sample, we're going to go ahead and analyze that data. And that's something that we'll learn about as we move through the course. Kind of starting in chapter 5, we'll get into deeper probability analysis of the data. And then we can use those probabilities to make claims about the population. So if you think about the smelling Parkinson's activity that we did yesterday, we saw that there were a very small number of students that were able to correctly guess 11 out of 12 of the shirts correctly. And so that, or those few students was so unusual that we would say that it's highly unlikely that she would have been able to smell Parkinson's just by guessing. And so that's the claim that we're making about the population, or the inference that we're making about the population, based on the probability from the data. So our probability was very low that we'd be able to correctly guess. And so we can then conclude that she was not just guessing. So as far as categorical variables go, that's our focus in section 1.1. Like I said, categorical variables put individuals into a group or a category. And so the distribution of that categorical variable is basically just going to be either the count or the percent of individuals that fall into each category. So we have an example here, and it's on page 8 in your textbook if you wanted to take a look in more detail. But basically, they just looked at different radio stations and what category those radio stations would fall into. And so in this first chart over here on the left, we have what we call a frequency table. And so all a frequency table does is it gives you the count of radio stations that are in each of those radio station categories. Over here on the right, we have the same data, it's just presented in a different way. We have what's called a relative frequency table. And so what a relative frequency table does is it gives us the percent of radio stations that fall into each category. So essentially these percents over here on the very right-hand side of this chart are just found by taking the count divided by the total number of stations, and then the same, the count divided by the total number of stations down here at the bottom. So just some vocab terms that we've seen to show you where they show up. We've got the variable, which is the radio station format. Again, it's categorical because it's putting the station into a category based on some common trait. And then the values of that variable are the different outcomes, so the different station types. So here, just this arrow is pointing to one of the values for news talk. Another value would be country. Another value would be contemporary hit. And then over here, like I said, in the frequency chart, we see the counts. And then in the relative frequency chart, we see the percents. So when we go ahead and make a graphical display of categorical variables, there are a few different choices that we have. we can make either a bar graph or a pie chart. And basically that's it for categorical variables. That dot plot that you saw with the miles per gallon earlier is a graph that we would use for quantitative variable. Remember, miles per gallon is a numerical value that makes sense to find an average of. And that's, again, what we'll focus on in section 1-2. So here, the bar graph is something that you can easily make either using technology or you can just draw by hand. Your bar graphs are going to go ahead and have the variable outcomes, so the different station types in this case on one axis, and then the number of stations on the y-axis. So we've got the frequency over here. You could also have the relative frequency for the bar graph, and so put the percent of stations on the y-axis, and that would be correct as well. A few things that are important to pay attention to with bar graphs is that you always want to start your y-axis at 0, because if you put an axis break in on the vertical axis, what you're going to do is you're going to shorten all of those bars, and then it's going to exaggerate the differences between the categories. So you always want to make sure that you start at 0. You also want to make sure that all of your bars are equal width, and you also want to make sure that you're leaving space between bars. So the space here should be the same as the space here, and so on. So leaving equal space between the bars, and then again, the bars should all have equal widths. And the reason for that is because when you look at a bar graph, your eyes kind of respond to that visual area, that first glance. And so if you didn't leave even spacing between the bars, or if you made one bar significantly wider than the other, then you might inadvertently think that that bar is representing more than it actually is, just because it's wider and it takes up more space on the page. So the other type of graph we can make, like I said, is a pie chart. Pie charts are always going to be showing percentages or proportions. So here we use that relative frequency chart to make the pie chart. And it's showing us the same information that the bar graph is showing on the left. It's just in a different format. With that pie chart, like I said, it has to give you those percentages. So it has to add up to 100%. If for whatever reason you were missing a category, or in this case, it was probably more likely that you just had some stations that really didn't fit into any of the categories given, you'd make sure you include an other slice of pie. Something to be critical of when you're looking at kind of news sources is just make sure that the graphs actually look statistically sound. A lot of times you'll have graphs that are presented like a pie chart where 25% is not representing a quarter of the pie just because they're trying to influence the reader of the graph in some direction. So really kind of keep that in mind moving forward. Look at the graph and make sure that it looks the way that it should based on those numbers. As far as pie charts go, we really want to try and avoid making the pie chart by hand just because it's very difficult to visually distinguish between maybe 11% over here and 9% over here if you were trying to draw that pie chart by hand. So you could let a computer create it for you unless you absolutely needed to draw one by hand. We'll let software take care of that. Here's just a little comic for you. It's a little cheesy, but your textbook likes to put those comics in there from time to time. So like I said about bar graphs, they compare the different quantities by looking at the heights of the bars. So it really is important that we're focusing on the heights of those bars. Again, reiterating that starting at that 0 on the y-axis is important. Like I had said, your eyes are reacting to the area of those bars. So you want to make sure that those bars are equally wide. And then also kind of going along with that same note is to avoid replacing those bars with pictures just to kind of make it look fancier because that can be misleading. And there's an example, I believe it's in your homework, where it's talking about transportation to school and they've replaced the bars with like a picture of a school bus or a picture of a car. And so the school bus just takes up more visual space than the car. And so it's misleading. It's making it look like maybe more students take a bus to school than a car, for example. Here's an example of a bad graph. So I'm going to give you guys a minute to just look at it and see what you notice. Is there anything looking at that graph that you feel like is misleading? Okay, so there are a few things in this graph that I notice. The biggest one, I think, just based on what's on this slide, is that equally wide bars. You have here a much wider bar for DirecTV than the other two types of TV providers. And then another issue is the vertical scaling. So again, we don't have a labeled y-axis over here, but if we did, we would see that there's going to be an issue with consistency of spacing. So the difference vertically here between 56 and 81 looks very small compared to the difference here between the 81 and 95 vertically. So proportionally, they don't really stack up. And then one other thing that some students have noticed in the past is that for DirecTV, they put a few icons here for some stations that they have, and you see no stations over here on the other two options. Okay, so your homework assignment is to do a few problems in the textbook. So you're on page 22, numbers 9 to 17 odds, and then you will find that there's an assignment in Schoology for you to upload your work. So just take a clear picture of your work, or you can scan it or use a photo scan app and then upload your work to the assignment in Schoology to get your homework points. And then what will happen is I'll just grade your homework based on submission and completion. And then in our next virtual meeting, or synchronous meeting, I should say, we'll discuss any questions that you have about that homework assignment. If you have questions as you're working through, or if you submit the homework but you know that one of the answers is way off, you got stuck, feel free to send me an email and I can address that before our next synchronous meeting. But just know that we will go over any homework questions prior to starting a new set of notes for kind of future lessons. Something else that you have out there is that Khan Academy has very nice resources to kind of go along with what we do in class for AP statistics. So I'm going to put these at the end of all of the sets of notes that you'll see this year where it's applicable, which is in most cases. This is totally optional. I'm not going to go in and check who's doing what. But if you find that maybe you missed something along the way, or you're having difficulty with a certain topic, or you want some extra practice, you can always go to Khan Academy and find that AP stats. And then the topic for today is the analyzing categorical variables.